pantalla cuando queráis.
Okay. Good morning, everyone. It's my pleasure to introduce you the speaker of today. He is Josep Lluís Arcos, research scientist at the Machine Learning Department of the Artificial Intelligence Research Institute, one of our neighboring CSIC institutes in the campus. He will present us his talk, Artificial Intelligence and Biases, Myths and Facts. Since I guess he will try partly to reassure us on artificial intelligence, I would like first to challenge him and you with a few thoughts. And for that, I will use a few slides myself. So I'm going to share my screen and cross my fingers. Can you tell me if you are seeing the right presentation in the right mode? Perfect. So you know, I try to be fun usually. Here is my first question, so to say. With so much hype and hopes, is artificial intelligence a fairy tale with a stepmother? Un cuento de hadas con madrastra? Apparently, we are to rely on algorithms now as the ultimate truthful and trustable referee for all our choices and decisions. But I think that one relevant question is, will a 100% truth-based society be a functional society? Is it really necessary to expose all of our lies? We are sapiens, and you know that lies are a kind of social ointment. You remember the TV show Lie to Me. It's how exhausting should be someone that knows, you know, to trace all your micro expressions and be able to know if you are telling the truth or not. Also, if we are also let an algorithm to decide for us, another couple of questions. So, are the people behind it, do they have an agenda of their own? Are we going to be tyrannized by algorithms? You know that Google has an algorithm that sort your search hits, and YouTube has an algorithm that also to play some tricks with the viewing hits. Okay, and there are some science communication people already burnt out because of the YouTube algorithm, how the videos are rated. And another question, do these algorithms really work as they should be? I'm not going into it, but I'm leaving you with this link of just a test case that some journalists in Germany did on a specific artificial intelligence tool for helping make decisions in job candidates, you know, interviews for job candidates. And apparently it should be objective, but in the end, there were some problems, okay? And just as a kind of, for a taste, these systems should be able to gather from the speech and the video some traits of the people and give some marks on things like openness, conscientiousness, extraversion, so on and so forth. And it resulted that the same speech from the same person, but just with little tweaks, like wearing like glasses or wearing a scarf, gave very different results. So is it really working? Is it working properly? So, and this is just my final slide. I chose a Snow White witch, because you know that in Snow White there is an artificial intelligence device that is a magic mirror that helps to give the right answers, who's the fairest of them all, which in this case particularly fair in English also serves for the purpose of the job candidates. It's not only just good looking, but also appropriate. And just, we all know that in the technology field, when we glorify a technology, we usually also give rise to modern dystopias. So we can go from the magic mirror to the black mirror. And if you haven't seen the TV show, The Black Mirror, you're missing something. So go for it. And that it's all from my side. So I really leave the floor to Josep Lluís, that probably has something much more interesting to say than me. Thank you very much. So I will quit sharing. The screen is yours. Remember to unmute yourself.
Yeah. No, I'm just trying to. I don't see my presentation. Sure. Okay, here. Okay. Thank you a lot for the invitation. So it's a pleasure and also a challenge to me, because in some sense I have to sell my work or our field, and at the same time I have to really say, hi, take attention about what we really can do or what we don't really can do. So first of all, so I will try to start just trying to just pose the questions that maybe we can try to discuss during the talk. So the first thing is that, who do we care about AI? So we had this interesting introduction. So in fact, we can change why do we by why should we. So this is the first thing we will try to describe or to show, to explain. The first question, the second question is that why we use or why we need really AI, what it can be really interesting to use these tools. I think that it's interesting to understand why these tools can be useful and why they are really doing. So the idea is that when we use these algorithms, what we are really doing. So I think it's important to understand what we do, because if we understand what we do, not in technical details, so just in a broad view, so maybe you can understand what we can really do with them or not. Okay. So another thing that I will try to show is that, okay, sometimes so these algorithms are really complex, and sometimes people are saying, okay, we are using a black box. So it is that, do we need to understand what is the black box doing or not, or why? So this is another question that I think that is really relevant. And at the end, so I will try to really summarize what are really the biases that we have when you use this kind of tools or technologies. Okay, so the idea is that why do we should care about AI? So the first thing is that because we know that AI now is becoming a kind of broad technology. So, and especially because we know that some of big companies, so the Google, Amazon, Facebook, Apple, so the GAFA companies, so they are really concentrating a volume of information that was not really concentrated before, and they also have competing facilities that, okay, they can do things that maybe were not really feasible some years ago. Another thing is that also from some governments really, okay, they are thinking that, hey, maybe we can use these technologies to do specific things, and okay, we can discuss this kind of things that can be done by our governments or not. And at the end, so one of the things that probably are behind of all of these things is that since this is a kind of new technology, there is a lack of effective legislation, in the sense that, okay, maybe we can say, okay, we should do things in this way, but okay, maybe at the end, there are no effective ways to really force this to be done. So this is probably why people is really care about that. So, and also there are additional things. Black Mirror is one of the TV shows that was one of the first one of that. But I think that there are also other sources like this, two really interesting docs that are the social dilemma and this second one that is like coded bias. That okay, probably many of you have really know about these dogs, and they are just pushing a lot of things on that, on why AI can be really terrible or not. So I think these are interesting discussions. So regarding these two dogs, so I think that there are many things that are important. So the first thing is that these big companies, what is the goal is that they are competing for our attention, in fact. So this is the goal, not to use sexy technology for just being a more good society or for the. So what they are really doing is that they are, in fact, exploiting our weaknesses. This is what they do. So they use another term. They are not saying this. They say, okay, we want to promote the engagement. But at the end, engagement means that, okay, since they are trying to sell things, just putting more ads, just trying to earn money from us, okay, they need this. They need the engagement. They need that we must be there all the time. Okay, so this is the goal they have. So at the end, what they use is they use what is called a persuasive technology. This is mainly the kind of things they use. Of course, AI and computer science play a role important in this, but what they are doing, in fact, is trying to exploit this, trying to exploit our weakness. That is not really bad or good. This is what they do. Okay, and this is why we think that probably there are a lot of contradictions about using AI. Okay, I also want to really share with you all the books that probably many of you may know, or if not, so some of them are really interesting. So that all the guys that also had pushed things regarding AI and how AI is really working now and why maybe we should change the way we use AI. But again, there is, as ever, there is two sides of the coin, in the sense that, okay, one thing is that what AI is doing, another thing is that how we are using AI, that it depends a lot. So two things are related, but are not exactly the same. So this is why I think that we should try to first understand what AI is really doing, or how AI is working in some sense. So the first thing that I think is that AI is interesting because we want to really use techniques in some fields that we don't have really a complete understanding or complete models about all the fields. For instance, we don't know exactly all the things regarding the human body. So since we don't have a complete model, we cannot, for instance, apply a collection of equations to calculate things. So we have only partial information regarding that. So we need tools to help us. So this is the first thing we should take into account. So the idea is that there is lack of complete knowledge. And the idea is that, okay, let's use AI as a tool for generating hypotheses about possible things or possible models about these specific domains, and use this as a way to really learn more things or have more complete understanding or knowledge about different fields. This is the original idea. And of course, if we have ways to generate hypotheses or to generate models, we can use this as a tool to approximate solutions. Okay, we can propose solutions for solving things. Okay, so let's just exemplify this with I think this is a nice example is the system AlphaFold. So it is, okay, they are just providing a collection of possible solutions for a problem that we have only partial understanding. So they are just providing possible ways for protein unfolding. Okay, so the idea is that, okay, the goal is not really to provide solutions. The way is to put this tool in a process, in a pipeline, where we want to really speed up possible hypotheses, focus on them, and just try to check and validate if they are useful or not for our purpose. Okay, so this can be really a good example of that. But of course, when we have some technology for doing things, we can start thinking, okay, we want to automate processes, because this is really a way to really do things better, or maybe to just decrease the cost of doing things. We can think in things like, okay, we can just check things like quality controls or diagnosis, or just recommend to the people things that in theory we can think that, okay, these are interesting things. We can discuss if these things are or not good for some purpose or for others. But okay, of course, if we can automate things, people can say, okay, we can, if we have models, we can predict the future. Okay, and this is when we start doing things at sometimes that, okay, since we design plausible models using the past, okay, we have to care about that, because if we are using the past to design this, maybe what we are really doing at the end is, in fact, to replicate the past into the future. So the idea is that, okay, if the past was good for me, I want to really follow the same path, but maybe it's not good for anyone, or maybe we are not really trying to do things better because we are just replicating the past. Okay, but in many fields, it seems this is good enough, or at least people that want to really earn money at some point is really using these things to do some kind of solutions. Okay, so to understand more or less how this really in deep these algorithms work. So when we deal with AI, we are mixing two different sources of information. So one is knowledge we have as a society in different fields, scientific point or experience, and the other one is data we have regarding this. So we have examples, we have instances of things we did, and we can just use this to learn things. What it happened at the beginning is that, okay, the world, when AI started, that was at the same time that computer science started, so the world was not exactly balanced in the sense that, okay, the world was not really digital. We had more or less a lot of knowledge in other sources, not really digital, but we had this knowledge, and we didn't have really the availability to exploit data because the world was not really digital. Okay, so just to understand the starting points, okay, there was, okay, let's just use human beings to just codify what we know about different fields, and we can just build these knowledge models. Of course, if we are able to do that, we can just use general purpose inference computer science algorithms to just try to solve new problems. In this case, it's just using for diagnosis in the clinical domain. This was the original approach, and okay, there were some successful examples, but the problem was that, okay, since the knowledge is changing and therefore for just codifying this is really high, sometimes this is not really something that we can maintain along the time because this costs a lot of money, we need people on that, and okay, it was only partially successful. So the idea is that, okay, at some point, so the world started to be more digital, so this means that we had a lot of data that was really digitalized or was really directly coded in digital sources. And okay, we started thinking, okay, since now we have more data, maybe we can think in another way. And there are some guys that say, okay, maybe we can just ignore the knowledge we had regarding different things. I don't agree with this view, but there are some guys that say that, okay, if we have enough data, maybe we can only work with the data. But of course, like I said before, so we only have data regarding the past. We don't have data regarding the future, okay? So the idea now is that, okay, since we have data, we can say that, okay, the data can be divided, and simplifying a lot, in two kinds of sources. So one are the observations we have regarding any kind of problem, and we have the target, what is our goal, okay? So it is that, okay, we can try to modelize this using a kind of mathematic functions. And what we can do is that, okay, try to really determine the target, just trying to compute something from the observation. So the idea is that this is wonderful, because what we can do here is that we can just generate these models automatically. So we can just generate knowledge automatically from the observations. This is the more or less the machine learning approach. So okay, this was the idea. But of course, the problem is that which are these kind of mathematical functions we will use to really model the world. We have really thousands of options. So we have to decide something, and probably we cannot test anything, okay? But at the end, so what we do is this, is that, okay, we have we have data, we have these pairs of observation solutions for different items, for different subjects, for different sources. And then what we want is to really find which is the best approximation, it is the best function that minimizes the error. We are just minimizing the loss. Okay, this is what we are doing at the end. So the idea is that it's really simple. So, but we have to take into account different things. So the first thing is that, okay, each algorithm we choose to solve the problem, it will use probably a different hypothesis space. Maybe we are just dealing only with polynomial equations. So this means that our solution will be only in this space. This is one of the things we have to take into account. So the second thing is that maybe we have different alternatives that present similar laws. So this means that why not? Because we are just trying to find functions. We are not trying to really understand in a deep sense the source. So we are just trying to find models that fit with our data. Okay, so this is one thing we have to take into account. Sometimes having multiple models or multiple solutions, sometimes this is a problem, but sometimes it can be really interesting. For instance, if we just take an example, this is a simple example. If we have people and we have a lot of music resources, and what we want is really to recommend music to a guide. So for instance, in this case, what we want is to know is that for this specific music, if this can be interesting or not for this guide. So, okay, so we can use different models. We have multiple choices for proposing different music. And okay, there is no really a crucial problem if we just use different models, and okay, different models will do different things. We can mix different models. If maybe at some point there is one music that is not really good enough for the guide, there is no problem. You can just use other alternatives, and there is no problem in that. But this is good for this kind of problems, but for others, maybe, for instance, if we think in terms of clinical domain, okay, maybe this is not a kind of solution we can really use. Okay, this is one thing. The other thing is that, okay, what I say is that we are trying to minimize the loss. But what we know is that sometimes maybe the model with lower loss is not really the best model that we want to really find. So let me just show in a really simple example. Suppose that you have really the true function is that is in green, but at the end you don't have the function. You only have some samples, and of course with the samples there is some error of the measure or some errors around the sample. So this means that what you have really is these blue dots. So we can approximate this function according to the data. For instance, just here using a line. Of course, if we use a line, we will have an error. Okay, we can just try to increase the degree of the polynomial solution, and what we know is that if we reach degree 15, we will be really more close to minimal loss, and we can think that, okay, this maybe can be a solution. But in fact, what we know is that here in this example, because we know the real function, that if we just stop at degree 4, so probably we are really approximated better the solution. So what this means is that, okay, there is really here an uncertainty, which is really the model. So usually what is known here is that, okay, usually you are using the Occam-Treasure strategy, and it says, okay, let's to minimize the complexity of the model to fit the problem we are dealing with. But this is just a decision, because we don't know exactly where is really the green line. So we are just taking a decision, and this decision is a decision we take. So we can think that we can do this for any problem. We can take the same decision, or maybe we have to really analyze the solutions, analyze the proposals, and see more things after this analysis. You cannot just take the first solution that we really achieve. Okay, so as a summary, so what the idea is that, okay, which are really the hypotheses that are behind this kind of algorithm? So the first hypothesis is that, okay, we don't know exactly the real function or the real model, but our hypothesis is that we can model our problem according to the hypothesis space we are using. But this is just I guess we are not sure about that because we don't know exactly the model. So we have to deal with this. Okay, this is the first hypothesis and the first problem we have. The second thing is that if we want to learn something, we have to be clear that our data is representative of the problem we want to really deal with. So for instance, in the example that was exemplified in the introduction, okay, so if we want to really analyze image data regarding people, we have to make sure that we have all the data we need. And sometimes there is a kind of problem because sometimes people say, okay, I have a lot of data. But having a lot of data is not exactly having a coverage about the problem. So you have to really be sure that you have the data you need that is important for your problem, or what is exactly the problem you want to really solve. You have to really define this in an accurate way. So this is the one thing. And the other thing is that you don't only need volume, you also need quality. You need a minimal quality. We know that there will be noise, there will be some issues with the data. We don't need exactly perfect data, but at least there is a minimal quality of the data that should be there, okay? And finally, also, it's not only needed to really have data and to have enough. So we have to be sure that we have data more or less uniformly distributed along the region of the interest that we are dealing with. Because if not, maybe we have a lot of data of this issue, but we don't have really data regarding all things. So we have to make sure that we have this. So these are hypotheses that, okay, maybe in our problem, you cannot guarantee that all these things are there, but at least we have to measure which is really the percentage, or which is really the quality of the things we have behind the problem we want to really solve. This is really important, and sometimes people is really skipping this part. Well, I have data, I have a lot of data, so I can do things. Okay, maybe you have a lot of data, but your data is not really relevant for the problem you want to really solve. And this thing is not really trivial, because if we are dealing with models in fields that we have partial knowledge, we are not ever sure that we are really modeling the features that are important, because we don't know exactly which are the really important features. So this is really important for that. Okay, so when I just presented the framework, so I presented this, we have observations and we have just our goal, but I have to say that sometimes we only have observations. So the idea is that we don't have really the solutions, and we have to deal with that. We can just extract patterns from this data. We can do that. But since we don't have a solution, extracting patterns, I think that is really important to generate hypotheses, but it's not really enough to generate solutions, because we don't have a way to contrast. Okay, this is one thing. The other is that maybe we have some solutions, or we have some target values for a subset of our data set. This is useful, because annotating the whole information we have probably is really difficult. So we can deal with that. So let me just show an example, just to illustrate what we have at the end with the algorithm. So suppose that we have this data, this a collection of labeled instances. What we are really doing with these machine learning approaches is trying to just find the decision border. Why we are trying to do that? Because we want to really split the space. We want to say, okay, below this border, all the instances are blue. On top of this border, all the instances are red. Okay, that's true. That can be a way to do things. But let's suppose that we have exactly the same labeled instances, but we have a collection of data that we don't know if they are blue or they are red, but we know that they are in this space. Okay, what we can think is that, okay, maybe our border now should be changed. Maybe now we can think that, okay, it's better to just define this kind of border. But this is just an intuition, because we are just saying that in this way, but we are not sure in fact about that. The real thing is that, and this is another field of machine learning, that it says, okay, maybe we should ask at least to some experts regarding some of the instances that we don't have really a label, and try to validate our hypothesis. If we are not really able to validate the hypothesis, we will not be sure if our model, our best model, is the model on the left or the model on the right. Just because we see some dots here, we can think, but this is not enough. Okay, and this is really important. So again, if you want to be sure about your models, probably you will have to really put extra effort here, okay? And just to conclude all this part, so there is that, okay, sometimes another jump, people is just doing a lot of mortal jumps in the sense, okay, if there is a correlation between the data, okay, we can say, we can conclude that, okay, one thing is causing the other one. This is just an example. This website is really fantastic because it puts a lot of examples. So this is a thing that, okay, just analyzing, if you want to really know the rate of splits in main, in some sense, so it's really easy. The only thing we have to really focus is just to try to compute the consumption of margarine. We can see that if we just analyze the first line, so we can just infer the second. This is really interesting. So, but of course, any of us can really think, okay, this is really a silly thing. What I want to say here is that, okay, this is clear that probably these two variables are not really effectively correlated because we know the meaning behind that. But the problem is that if we have a previous bias that we think that these two variables are really important, we can conclude that we can analyze in this way. Let's see just two examples. This is one of the examples that you can look at. So at some point around the end of 2009, so Google will say, okay, I have a way to really anticipate the epidemics of flu in the world, just trying to analyze the queries that people is doing. Okay, so what we can see from these images is that, okay, for the first year, everything was working well. The second year, more or less, they were working well, but the third year was not really working. And mainly because, okay, they were using what they have, were the queries, but why are really sure that we are really sure that the queries are enough to analyze that? So what I can say now is that Google is just deleted everything. So this project was canceled. And in fact, if you want to really find about that, so this is a demonstration that Google can really delete things if they want. So you will not find easily why this was at some point the solution of nothing. Okay, this is one example. This is another example that was also around 220. It was really announced that, okay, Watson will solve the problem of cancer and will use a kind of partnership with an important hospital in the world and blah, blah, blah. And okay, they worked it and they promised that, okay, we have solved this problem before doing anything. So the idea is that now, if you just try to look, what they do is that, okay, they were not really able to solve what they were saying. But again, why they were saying that? Because they need to sell things, not because of science or because of, so the original Watson was really interesting. So that the technology that goes behind that was really able to win the Jeopardy contest in the United States was really amazing, but it was for one specific purpose. It was not really solving anything in the world. So at some point, so there are a lot of interesting things there, not to sell that you are solving because you don't have really all the key items that I explained at the beginning that you need for solving this, especially because if you don't have really enough knowledge about everything that is happening around the cancer, maybe you have to really take another approach. That is, maybe you have to really help people to propose things, to make hypotheses, not to really provide solutions. Okay, so just I want to use this picture to show you that we have a lot of techniques, a lot of algorithms for doing things. But what it happens is that those that are more explicative, or those that we can understand more easily, are those that are not providing higher accuracies. And now we have new technologies, especially deep learning, that is providing apparently high accuracies numbers. So they are really good in doing things. But at the same point, since they are really complex, it's really difficult to explain what they do. So my question is that, do we need to know what they do? So it depends on what we want to solve. So there is no unique answer to that. So it is that, okay, maybe if you are in a domain that you don't have really a complete understanding about many things, maybe you need to at least understand what the algorithm is doing and why the algorithm is choosing this feature and not other features. You need to understand this. But maybe in other domains, you can use also AI to solve interesting things without really knowing the details. For instance, this is the example I just mentioned at the beginning. If what you want is to propose examples to predict the structure of proteins, this can be a way to really speed up the process. Okay, maybe you will not provide all the combinations, but if you are able to provide enough good combinations, this is a starting point that is really useful for other fields. So this is really important. In this way, it's really necessary to understand in deep the model. Maybe not for, of course, for our point of view, for the experts in AI, we need to understand because we want to really do things better. But maybe for this specific problem, you can really use this solution. And using this solution, you can do a lot of things, okay? But of course, if you want to decide if this guide is good enough, I don't know, for doing something, maybe you should understand why the algorithm is doing at the end, okay? So at the end, so I want to just conclude my talk. So it is that why these biases arises at some point, okay? So the first thing is that we have to really determine which is the problem that we want to solve. For instance, when people is saying that, okay, we want to really automatize credit worthiness. Okay, they are not really doing that. What they do is that, in fact, they want to maximize the profit. Okay, this is not bad or good. So we have to really define what they are doing. Okay, for instance, if you want to select people for jobs, what do you want to do? If you think that, okay, there are at least significant guides that are good, if I have a way to select easily the people, okay, I don't mind if some of the most brilliant will be not in the final subset. Okay, maybe if this is your approach, you can do this in some way, but you are not really choosing the best candidates. And this is the same. If you want to really, you are thinking in a short-term profit, in a long-term profit, so it depends on that. Okay, but you have to define exactly what are you doing. You want to select guides and you don't represent the diversity of the whole in the subset. Of course, you are not selecting the people according to the whole. You are only selecting the people that fits a specific, I don't know, conditions. Okay, so this is one thing. The first thing is that you have to take care about what it means collecting and preparing the data. Usually what people is doing is that, okay, I have this data. Since this data is there for free, I will use this. And sometimes, I don't know, sometimes people, there is no really analysis that if this data is really interesting or not for doing what I want to do. And also, since we are a kind of society that we like a lot gossip, so we need, okay, maybe since to solve my problem, what I need, okay, let's make a list. Maybe the first thing is I need all the GPS positions of the guides. Why I don't need, why do you need this? I need, I don't know, I need if they are buying margarine or they prefer other kind of things. If they buy a car or they just take public transport, these are the kind of things that some original companies are collecting because other purposes. And now it seems that also governments like to do that, but it's not clear that you need that. So maybe for doing what you have to do, you need other things. But since many of the companies, the value of the company is not exactly the algorithm. The value of the company is the clients, the customers, is ours as users. So this is why they need to collect many things, because the value is in another path, not on the algorithm, okay? And finally, so what it means when you are measuring the performance of something. Usually the typical scientific approach is that, okay, we have one data set, we split the data set in training and test, and that's all. But what we know is that if there is a bias in the training set, probably the bias in the test set will be the same. So this means that everything will work well because we have the same bias in the both subsets. But okay, what we are really doing with that? So if the idea that we know that there is this principle that it says that, okay, if you don't have the appropriate data at the beginning, we are sure that we will not have the appropriate model at the end. Maybe apparently you will find things that are interesting, but maybe just because at some point the randomness is saying that, okay, you can achieve anything from anything, okay? This is one of the ideas. So the idea is that, okay, if in addition, what we are doing is that we are just dealing with decisions that people is really involved on that, this is not really a technical problem, or it's not really only a technical problem, because then I think that this is more a kind of more ethical or kind of most problem regarding the society. So the first thing is that, okay, maybe we are collecting information regarding the guides, but we don't have really the real social context or the real decisions that were behind this decision. So just saying that just these observations are significant to really understand the guides, okay, you can think about that, but okay, I'm not sure about that, okay. And for instance, this is just an example. So if we are now for the future, we're trying to use the data we have around the world for the last 2 years, what we can do with that if maybe next year COVID will be not present on that. So the circumstances, the context is really different. So maybe we will not be able to use this data because, okay, people maybe was not moving because many other things. So if the circumstances are changing, or again, what we can predict regarding the data that we had previous to COVID, regarding things that will or are happening now during the COVID? Nothing, because there are a lot of things that are. And at the end, so one of the problems is that what it means fairness, what it means ethics. So the idea is that, okay, we have different definitions on that, and we have different guys that can push more or less what they think about that, okay? So just to finish my talk, so what I have to say is that, okay, at least it seems that we have a collection of European laws, so we have a kind of framework, at least in Europe, that says interesting things, but I'm not sure these things can be really enforced or not. For instance, it says that anyone can, if any subject wants, can not be subjected to a decision only from computers. Okay, this is, at least the law is saying that, but not sure if this is something that we are enforcing or not. And mainly because one of the things that we need to deal with these kind of things to really make sure that we are doing that is that things that we do are transparent, and at least transparency and accountability are things that we can really make sure that are there. And we know that, for instance, at least for the government, this is really difficult to really have this level of transparency and accountability. So it means that if governments are not really providing these capabilities or these features, why we should force private companies to do more than we are able to do in the public sector? This is one thing. And the other thing, so I think that here is, there are a lot of things that are important, but maybe the last red box that is on the bottom is really important, that is just coming back to the mathematics or the statistics. If we know that there is a distribution of something in a population, if we take just a subset of this, or if we take just one guide from that, so this guide is not the mean, this guide is not the deviation, this guide is a specific guide. So we cannot really say anything specific about this guide. We can say, okay, there is a probability of this guide is in this way. At the end, we have to take a decision. So, and we want to take a decision using only probabilities. Okay, it seems that some governments are really happy to do this because they feel that, okay, it's not important the individuals. If the individuals are not mine, they say, this is one thing. But I don't know, these are kind of things we have to discuss or have to really decide as a society. It's not a problem or a general problem. So just as a final remark, I think that this sentence that I think that is really good, it's not mine, it's from the Dictionary Banks, that it is in one of these documentals. So the idea is that, okay, we are here, so AI is here. So, and there are a lot of possibilities. The problem as at any new technology that is coming is that probably is not evenly distributed. And we have to really fight for really apply the same rules to the whole population. And that's all I want to really share with you. Thanks.
Thank you, Lluís. It was a really good talk. I think it was of much interest for everyone. So thank you very much for your time. We open now the Q&A. So we have here the researcher. You know that you can write your questions on the chat or maybe turning on your microphones, whatever you want. I'm gonna go with the first question regarding the biases. And I mean, you talked about the guidelines, framing the problem, collecting and preparing the data. But in terms of, for example, you or your colleagues at the Institute, do you have any specific way of checking that you don't fall on biases, that you are not repeating these patterns of behavior?
Yeah, there are some things that you can do. So it's not really a technical problem per se. So the main thing is that you have to force the guys that are selling things that they have to demonstrate that they passed these checks. And usually they don't do that. So in the example of one of the dogs, so the example was really nice. So there was one of the researchers that was not able to be identified because of the face, and at the end the face was the problem of. So you cannot say that you don't know this, because you know the statistics of the data you have. So usually people say that, okay, I have data, but I don't know what the data is. Okay, of course. So, but this is really just an excuse. So it's just doing, okay, I have some data, I have a really good result, but scientifically, I cannot really provide the data, I cannot really provide the demonstration of what I am doing. This will not pass a reviewer in a journal, at least in our field, usually. So this is the same. So the tools are there, many of the tools are there. And sometimes what you have to really fix is that to say exactly what are you doing. It's not important. Maybe you are doing less than you want. Okay, but be fair. Say what are you really doing. When you say that, okay, we are selecting personnel or we are selecting people, it's like because you know that probably more there will be, I don't know, 100 possible good candidates. So it doesn't matter if I take any one of these 100. Okay, if this is the rule, okay, you are doing the things good. But then people probably will start wearing different things to just check. I will start registering to the site with different faces and different personalities and see what happens and just try to fight with the others. But you know that in advance. Or at least you should know that.
Yeah, of course. And in terms of legislation, there's the GDPR, the 2019 or 18 one. And is there any other specific legislation? Was that the first time it included this?
Well, this is the main now in Europe, and they are trying to put additional things. There is also another discussion now regarding AI tools, and they are starting doing a discussion, and they plan to do things in terms of EU velocity. That means that it will take 2, 3, 4 years to conclude something. But the main thing is not exactly if we have some legislation or no. We have also human rights as a kind of definition of something, but we are not really using human rights at many places or many decisions. So it's not enough. So it is that, can we really force to use this kind of things or not? And in terms of AI is the same. So there is this subfield of says that ethical AI. Not sure what it means, because some of the big players in the world are players that are playing like the world is playing. So what it means this? Okay, so I don't know. And sometimes the problem is that the government is the first one that is thinking that, hey, maybe we can do that. And they're exploiting some technologies that, okay, we know that, but they are not really transparent on that. This is the main thing. We have to really ask for transparency and accountability. Without that, we are lost.
Yeah. Okay, so is there any question?
Josep, Lluís, I have a couple of questions. You said at some point that, for instance, a very good application where AI has proved really useful has been this protein folding or whatever, no?
Mm-hmm.
Which will be your top 3 of the best used AI tools, so to say? For which applications you say, okay, this is a very clever way of using AI?
Well, I put this as an example because I think that is really a good example for many reasons. One is that because, okay, in a field that we don't have enough knowledge, we can help as any other tool that measures anything, or to speed up this. In the genetics part, there are also some good improvements on that, just using the technology. This is really good. This is the first thing. The other thing is that if you take care of the deep reading of the paper, they are not only using data. There are some experts on the algorithms, some experts on the domain, and they just thinking on the both sides, they were able to find a solution that maximizes the way the algorithm is looking for solutions. Okay, and this is really important because what we say is that data is not enough. We need knowledge, and what we can learn after that is that since we are learning the way that this algorithm is doing things, maybe we can just acquire more knowledge, not only solutions, also the way we can really do things. I think these are good examples of that, of doing that. And usually when I work in some of the fields, this is the problem, that they don't have really the complete model of anything. They don't have really a collection of equations that they can say, just following these equations, everything will be solved. So this means that if we don't have this is kind of interactive, or this is a kind of step-by-step improvement. We learn at each step, and at each step we do things better, and we just include more things, and this is what we do. And at least from the science point of view, this is what we should do. People that are selling things, okay, they are just providing ways of cutting complexity or just lowering cost. Maybe these things are good enough for all things, but they are not doing exactly what they say. They're just minimizing cost, but it might be fair. I'm not saying that this is not really good, but I'm saying that they should say what they say.
Mm. Just a curiosity regarding the example I showed in my slides about this tool for assisting in decisions with people applying for jobs. What is inside the black box of this tool? Because it should be able somehow to do some kind of speech recognition, vision. What are really the techniques there, the artificial intelligence techniques that are put into play with, if you want to go from speech and appearance to something like extracting psychological traits of a person?
Yeah, at the end, what are they doing is that, okay, in this case, there are two important sources that are images and sound. They extract patterns from this, and they try to correlate which are the patterns that better discriminate the collection of solutions I have, if they were really selected or not. This is what they do. But again, what is doing the system is trying to find the minimal subset of patterns that can map the input to the output, but they are not really providing anything regarding the knowledge about why some of them are better than others. They are just saying, okay, according to the past, we did that. Okay, so now we can do the same with less cost, because we are doing the same that people were doing, but with a machine, less cost. But we are not saying that we are doing better and that we are really selecting the best ones. This is what is false. But okay, this is what they're doing. It's like the example, this kind of camera recognition of possible guys that are really trying to, in the United States, this was really famous also, that there was some scientists that just take the images of the people in all the representatives in senators and also people from different Republican and Democratic guides. And okay, a high percentage of people from this subset were also selected as problematic guys. But since this is never the target, because they never will pass this kind of camera identification, they feel that there is no problem with that. But in fact, there is a problem with that. This means that, okay, they didn't really test regarding the true problem. They just that, okay, it's like just dealing with ants. If there is 100 or 1,000 of ants that are not really at the end contributing to the whole so there is no problem with that. So if you want to take people like this, okay, this is a way. But if you don't want to follow this way, you have to do things in a smarter way.
Thank you.
Thank you, Lluís. So any other question? Any other doubt? Anything? Even more book recommendations?
We have series, books, documentaries. There are a lot of recommendations on the table.
Yeah, we have work for the weekend.
Yeah, I think that, any of these, for instance, the documentaries are in, at least in Netflix. So if people is there, you can really follow. And there are a lot of interesting discussions about, because, for instance, in the social dilemma, I think it's good that they say, okay, the world is not black and white. So there are a lot of gray. So they started doing some things because they feel that they can be really help people. At some point, there are other issues that are in the middle. So I think it's interesting to think about that, because at the end, anytime that we introduce something that is useful, I can say that many of these tools are really useful. But the main thing is that if they are changing the way we do things, or they are just expanding the way we did things. People that was really interested in using all these social platforms for doing things better will have an opportunity to doing things, to be connected more people, and people that were interested in things before these social platforms, they will exploit now the platforms continuing doing what they did before. So we are not changing the way the society is doing things in this sense.
Yes, they are mirrors. So they act the way we do.
The good thing is that we have the opportunity to exploit these things to do more interesting things. I'm sure about that. So it's an opportunity, but of course, any opportunity, we have to really be sure that what we do is what we want, at least.
Okay, so if there isn't any other question, we will finish here. It's already 1:30. So that's it for today. Thank you very much, Josep, for the presentation. Thank you for your time. Thank you, Lluís, and everyone who attended today. We will see each other another day. And that's it. The talk will be available on YouTube if you want to grasp something else. And that's it. Thank you very much. Have a good Friday. Bye.
Thank you very much. Bye-bye.